Welcome to this 2.5-hour technical seminar sponsored by CGI, the Commission for the Management and Application of Geoscience Information of the International Union of Geological Sciences. My name is Harvey Thorleifson. I am Director of the Minnesota Geological Survey in the USA, and I am Chair of CGI. Today, we are pleased to be working with partners, the Loop 3D Geological Mapping Modeling Platform, the Deep Time Digital Earth Program, and the International Commission on Stratigraphy. Our objective today is to share updates on work regarding geoscience ontology and knowledge graph. We ask non-speaking participants to turn off their video and mute your audio. I will ask speakers to introduce themselves and their co-speakers, if any. For discussion, please use the chat or turn on your video and unmute. So in a minute, I'll initiate our opening remarks session. However, before I do that, does anyone have suggestions or advice for me? Okay, no suggestions, no advice, and I don't see any requests in my email, so I think we can go ahead. So I am pleased that we will begin with remarks from the partner agencies. First, we will hear from Francois Robida, past chair of CGI, regarding the CGI rule. Francois, would you please go ahead?
Thank you very much, Harvey, and good morning, good afternoon, good evening to everyone. I will be short because I think most of you already know CGI. Just to focus on some of the missions and objectives of CGI and also of its achievements that will be described later on by Mark and others. CGI has been created formally in 2004 as a commission of IUGS. So it reports to IUGS, and today we have a little bit more than 500 members in more than 80 countries. Zhang could provide some updates on that, but this is the estimate number of participants, which is quite large and spread all over the world. The mission of CGI is to foster interoperability and exchange of geoscience information. Not data, but information, really. And for that to cooperate with the members and with different organizations. I will not describe the complete mission, but just point on one of the 5 main topics, which is semantically rich and structured, and to enable seamless interactions in all environments. So it was described at the very beginning of the commission that the semantics was really a key and a rich part of the mission of CGI. The main achievements of CGI today have been to develop GeoSciML. We will have some more discussion on that. Earth Resource ML, which is used in minerals industry. And behind that, a lot of terminologies which are used to implement those exchange standards. I would say that apart from these documents and which describe the standards, a lot of work has been done to test and develop implementation. And this is and the training which come together with this activity of implementation. And now I would like to say a few words about the partnerships of CGI. One historical partnership is with One Geology. One Geology has been designed in some way as a flagship project to test and demonstrate the application of the CGI standards. And it's still true, and I think that Laurent will also illustrate the connection with One Geology in this project, in this 3D project. And The other quite important connection which have been created at the very beginning of CGI is the one with OGC. You know that OGC is an international organization developing standards for geo information in general, not only geoscience, but geo information. And really at the beginning, the idea was to build on the generic standards of OGC and to focus the work of CGI on the semantic part of the information, therefore GeoCML, the vocabularies, and so on. And today, I think we had Harvey, myself, and some other connections with, of course, with DDE, which is a new partner, I would say, and some of the projects around the world. And the idea of this meeting today was really to try to put all the ideas together and try to coordinate as much as possible the actions to make them more efficient and across the frontiers. And CGI certainly will be happy to continue to play this role as a partner. Thank you, Harvey.
Merci, Francois. Next, Zhang, would you please go ahead and provide context regarding DDE?
So hello, morning and evening, everyone. We'll show you a very recent news from DDE program and also the standard task group. So, I don't know how to play.
Maybe if you click on the slide, then advance.
Oh, yeah. Previous. Yeah. And the DDE is a very ambitious program of the IUGS launched in 2019. And the mission is to harness global deep time digital Earth data and share global geoscience knowledges. The vision is to transform Earth science, and the first paper was about DDE was published in Science in 2019. And DDE has primary goals is 8 goals, and important with CGI or geoinformation link the isolate data sets into an open system and make geoscience data and information going fair, and also promoting innovations researches for the 4 years. 4 years is the evolution of life, evolution of matter, geography, and also climates. And the schedule for 10 years will be finished in 2028. And maybe the medium-term plan is to next IGC in Busan 2024. And the kickoff was in Beijing at the forum of Big Science Forum, organized by IUGS mainly, and in February 2019. And so far there are 18 organizations as funding members. This year, 18 organizations include CGI and some Geological Service and some famous commissions from under IUGS also. And the program, there are leaderships and science committees and also the groups, working groups and task groups. As at the advisory board, there are governing council and the executive committee and the science commissions. And our CGI chair, Harvey, is in the governing council. And so far there are 18 working groups in different disciplines of geosciences, and so several task groups, and standards is one of the task group now carry out the study and also a guide for the geoscience data linked and for the also the knowledge graph or knowledge system developed. So this is the main or the characteristics of DDE is the data-driven knowledge discovery for the Earth science. So the data science is more important, and through the data science of the artificial intelligence And the DDE will transform the geoscience to be knowledge through knowledge graphs and ontologies, maybe new technology in data sciences to transform the earth science. And so the DDE, I mean the knowledge graph or knowledge system or ontology is very important for this transform of this data or knowledge-driven discoveries through a machine. So the DDE has in China side, I know many scientists involved in the 18 groups developed so many knowledge systems or knowledge graphs. Professor Hu will give detailed introduction afterwards. And for the standard test group and led by Francois in 2019, and then Harvey as the chair, we discussed with the IUGS and also co-data leaders and funding the test groups in 2019. And also we have working groups in early 2020. So we have planned all these works, our tasks, our findings, our mechanisms of the groups. So we get achievements for the review procedure for DDE knowledge system or knowledge graph, and also submit to DDE for use. And also we have issued DDE, the geoinformation metadata standard, and is a draft, now is circulated within the working groups and the DDE standard groups for comments for revise. So in the later October this year, we will have also a training for existing geoscience data standards and some knowledge graphs maybe, and also some new technologies in data-driven or knowledge-driven discovery for the training for the DDE. So that's all, Harvey. Thank you.
Thank you, Zhang. Next, Laurent, would you please give us background regarding Loop?
Yep. So thank you very much, Harvey, for inviting me to present a bit of context on the Loop platform. So my name is Laurent Ailleres. I'm from Monash University, and I'm the I guess the lead chief investigator on the Loop project, which is an integrated and interoperable, I guess these words are music to your ears, platform to enable 3D stochastic and probabilistic geological modeling. What we want to provide is really a platform where decision makers can input data, automatically build models, and automatically characterize the geology, but also the uncertainties associated with the lack of data, the quality of the data, and also the modeling algorithms, I guess. It's really to enable so decision makers once again to make decisions based on the best knowledge available and the best modeling algorithm available and the best data available. And we've done a lot of work for the entire workflow from going to start at the end, from uncertainty characterization to integration of geophysical data sets and geophysical constraints into the modeling engine. We've done a lot of work on involving structural geology constraints in the modeling engine. And we also have done a lot of work, and this is, I guess, why I'm here today, to look at the Geological Knowledge Manager, which is something developed by or led by Boyan Broderick with a team of people at GSA, but that's also involved collaboration with Rachel Evan, for example, from BGS, and people at like Nick at Geoscience Australia. We do adhere by the principle. So the project is actually under the auspices of One Geology. It was started by Chris Bygram. At the time, he was the chair of One Geology and the CEO of Geoscience Australia. We do adhere to the FAIR principles for data and for software. And really what we're interested in the work that the CGI is doing is looking at extracting as much information or as much knowledge as possible from possibly gray literature or the maps or whatever else. And we are data and knowledge hungry, and we want to feed that into the modeling engine to build the best models once again. So very quickly, the progress we've done so far in the data analysis. So we've automated the process of building models from geological maps served by geological surveys. So we read the outcrop database for the structural data. We read the polygon files, so shape files for geology, and we read the polylines for faults. And there is then a library called Map2Loop, which is doing a geometrical and topological assessment of the map. This is building automatically some sort of a graph representation of the history of the area, the geological history of the area, from deposition to deformation to later events. And that information, or that graph, if you want, is fed into Loop Structural, which is our modeling platform. And so, for example, I'm looking here at a rectangle that a user could be drawing. This is in the Flinders Ranges in South Australia. So you draw this rectangle, you press a button, and you wait about 11 minutes down here, and you end up with this model out here, which is pretty impressive, I should say. So the 11 minutes include the time it takes for the topological and geometrical analysis of the maps, but also to build the model. So because we have an automated systems, we're able to look at uncertainty, we're able to look at stochastic models, but we want to constrain the model we can build with more information. And this is where the work the CGI is doing is very important. Before I move on to this part, I just want to, if you're interested, there is a special issue called the Loop 3D Stochastic Geological Modeling platform in geoscientific model development. And so it's open source. It is open source, the software is open source. The papers here are open access. And I invite you to have a look. We have, I think, about 10 contributions at the moment. And contribution from the GSA, from Monash, from University of WA, and possibly from other people that I remember of, but sorry. And so where does the CGI fit in all this? I am not going to talk about this because this is actually something that I struggle understanding entirely, but this is a work that Buoyant Bordering is leading out of the GSA with his team in Ottawa. And I know it's also involving Rachel Haven from BGS and Nick, as I said before, from Geological, from Geoscience Australia. They have done a lot of progress. They've actually released the Loop Geoscience Ontology. It's also available on the Loop GitHub, and on the Loop website there are links as well to the paper from the release. We still need to work very hard to integrate that work into our data capture, if you want, in data structure, so we can use it to feed our hungry modeling and environment to build 3D models. So thank you very much.
Thank you, Laurent. That's very helpful. And so now, Phil, would you please provide background regarding ICS?
Yes, good morning, good day. Hello, wherever you are. My name's Phil Gibbard. I'm the Secretary General of the International Commission of Stratigraphy, and I'll attempt to share my screen. I've come at this meeting simply to introduce really the Commission and to talk to and to leave the detail to Nick. But the International Commission on Stratigraphy is the only permanent commission in IUGS. We were founded in the late 40s, and we are still not finished our work. It's an enormous task. Our present executive is shown here. You can see we have 3 voting members and 3 non-voting members. Nick is one of the non-voting members because his task is to look after all our data systems, of which we are increasingly building quite a network, and very exciting. Sorry, it's not what's happening here.
Maybe click on
the
the slide.
machine is refusing. Yes, should just change, but it is refusing to do so. So I apologize. Yep.
Maybe escape out and then try to.
I feel you actually have buttons at the bottom left corner of your. No, not anymore.
A button here. This one.
Yep.
Fantastic. Thank you very much. I'm not familiar with this system. Sorry. We have 350 members, and these are spread, of course, completely internationally. You've already seen the executive, and then we have a number of subcommissions, which I'll show you in a second. And the subcommissions are made up of voting and non-voting members. And we put proposals to IUGS, and the IUGS then ratifies those, hopefully, and that allows us to build what is in effect our main task. As you see, we have 17 subcommissions in total, one for each of the main divisions of geological time, plus a subcommission to look at stratigraphic classification, and a new subcommission, which has only just started work 2 years ago, on timescale calibration. Our main task is to build the chart you see on the screen, the International Chronostratigraphic Chart, and you see that's the latest version we have. We update it every time we put a new one of those little yellow pins in. The little yellow pins are for GSSPs, or global stratotype sections and points, which are international reference boundaries in the geological sequence. And as you see, this is not complete. We're still building this sequence today, but this is the latest version. Our major tasks then are completion of the chart with the various hierarchical divisions, which you've seen, and to establish links with the earth science community, and including obviously yourselves, research in the construction and use of the chart. The chart also for teaching and field applications, and of course outreach in a number of ways. We also have international translations of the chart in several languages. This is one example just to show you what it looks like in Russian, but we also have, of course, many other languages, some quite exotic actually. In addition, we have a mobile phone app, which I'm hoping that Nick will be able to keep up to date for us, which has a number of details that you see here, just so that people have references in the field. And our other data we're dealing with is the full information, as far as we can catalog it, of the individual stages. So in general, we have a very large amount of information, and it's increasing all the time. So finally, I just wanted to show you the front page of our existing website, which Nick is dealing with, and which Nick will be talking about subsequently. Thank you very much for your attention. I'm sorry for my hiccup with the changing. Finished.
Thank you, Phil, and thank you to all of our opening speakers. I believe that this is helpful for us all to see the context behind our more detailed discussions today. And Phil, please feel free to unshare your screen. I'm attempting to do that for you, but I'm sure we'll...
I've done it. It's done.
Okay, well, all right. So I'm just seeing a black screen. What is everyone else seeing?
I think it's working, Harvey. I can see you, and Phil's screen has disappeared.
Okay, all right. So hopefully my screen will update. So thank you, Francois, for providing context on CGI. Thank you, Zhang, for providing context regarding DDE. Thank you, Laurent, for providing context regarding Loop. And thank you, Phil, for describing the work of ICS. There, of course, are additional partners that we would be happy to hear from. However, these are the 4 that we chose to focus on today, but we appreciate the teamwork by all.